Hello. So, question number two. And honestly, I thought the question number two was just a free question because this is exactly same as what you did in a homework. So, I just had no time, so I made this question uh, to give you more points. But I was very much surprised to see your answer when I see your answers. So it's like what my feeling is like this. So I think I am a kind of language teacher. I'm teaching you the language in econometrics. That's my focus. Yeah, of course, the econometric intuition and statistical knowledge are important, but most of the basic knowledge, what you need, uh, is already inside you. You know what is expectation, what is probability, and intuition is pretty simple and just obvious. So, and what you need is to write down to explain your intuition, your knowledge, in a logical way, in a rigorous, uh, rationale and correct notation, and distinguish the terms, and so really understand the relationship between them. So I think it's a language class, and then my feeling is like this. So if you teach language to someone who is a beginner in English, for example, then it looks like that. Suppose that you are a student, you are teaching English to someone, and he or she said, I am student," for example. "I am student." Then you can fix the answer to, you have to put "a" in front of student, like "I am a student" is more correct. "I am student" is a little bit wrong. So "I am a student" is what you had to say. So that's what I think of myself as a teacher in this class. But the problem is, I understand. So in some questions, I understand what you wanted to say, and I know why you are wrong, and try to fill in the gap or what you are missing and why you are wrong. But the problem is, imagine like this: your student told you, say, for example, I am going student. I am going student. Then then the problem is, I cannot understand what sentence the student, like he or she, wanted to say. So does it mean I am going to be a student, or I am an outgoing student, or I am going somewhere? So to fix the answer, something is wrong. But to as a teacher to understand what is wrong, I have to understand what's the intention of this sentence. That's the problem I'm facing. I think, especially, I feel that in question number two, because I think it's obvious, it was in the homework, but literally I don't understand why you're writing some equations and why suddenly you talk about that. And literally, I don't know why you get to that idea. Out of what thinking? Why you are saying that? So it was really hard to grade, to not just grade, to comment on your answers. Just suddenly talking about something totally different. I'm not. I wondering if there was any problem in the question. But it does not look like there's any problem. So so also, I told you to be as rigorous as possible in your answer so that I can help you in doing that. But overall, it was a whole totally messy things going around, and I could not understand your flow of thinking. So it was really difficult to grade them. And let me just show you the typical answer. The answer I would write to that question. So there are two different approaches to identify beta. By the way, as I said, it is from the homework, so you know you know the answer. You should know the answer. The same conclusion as the homework question. There are two different approaches: moment condition approach and fitted value approach. In the homework, the approach was moment condition approach, and this is actually simpler, easier, and more concise to answer the question. But some of you tried the fitted value approach. It's not wrong, but fitted value approach requires more complicated argument to identification because it requires two steps and more assumptions at different places, but they are connected together. So in many cases, just for identification argument, like this question, moment condition approach is easier. Fitted value approach is easier in computation when you estimate the actual data from the actual data. Then fitted value approach may have some advantages, but in exam usually fitted value approach is not a good approach to answer a question, especially in identification wise. Anyhow, so moment condition approach, it's it's clear. Just you don't need to read it. Just look at the homework. Look at the homework. I gave you guide in the homework. So replace x is not observed. So replace x with w. Then the measurement error should be included in the error term, but does not matter. It's so the problem is w and xi is included in w. So this error term is correlated. U includes xi, w also includes xi. So they are correlated. So w is an endogenous variable. So you need an instrument that is z, another measure proxy variable, and z is uncorrelated with u because xi is a measurement error in w. Z has a totally independent measurement error, and z is uncorrelated with epsilon too. So you need to prove this, which is not that difficult. It's just also assumed. Say I have assumed all of the things. So x, eta, and like epsilon, psi, all independent, like epsilon, psi, epsilon, eta, psi, eta. So it's not that difficult to prove this. And then directly from here, you have this equation. That's the end of the proof. So you need a few more lines to show this, but just it's a combination of some assumptions here, and then the only assumption you need is this is non-zero, which plays the role of full rank condition. Rank condition is in here. Relevance condition or rank condition is in here, and that can be simplified to this. So z and w follow this functional form, and using these assumptions, it is also easy to show this equality. But even if you don't have this equality, the proof is complete as long as this is non-zero, right? So this is the best answer. But if you use the fitted value approach, then to be rigorous as much as possible, and to explain every step, you have to spend more time in the first stage regression. Not only in this question, but in any other questions, you are just saying first stage regression is like this. But that is right, though we know that will be true, but you have to prove that because I told you to prove every step. And so first stage regression is shown here. There is no intercept because w and z has mean 0. And if this typo does not equal to 0, different from 0, then you can define gamma this way. And if you define gamma this way, then z and v are independent, are uncorrelated, and gamma is identified because gamma is given by two identified objects. And then based on this, so you have to show that gamma is identified from the first stage regression. You have to prove this, or you have to show the first stage regression satisfies the classical linear regression assumptions. Anyhow, you have to show gamma is identified, and then go to the second stage. In second stage, uh, what you identify is the multiplication of beta and gamma. So this due regression of y on z, it satisfies the classical linear regression model, and pi is identified, and then after identifying pi and identifying gamma, you can identify beta as their ratio. This is the full identification argument to be rigorous. And you need additional assumption like this and like this. You have to verify them, and then in the end, the condition you need is just this one. This is all. If you have this, all the assumptions, this is satisfied by that, this is satisfied by that, and this is given from the question, and so as you can see, fitted value approach is usually longer to show the identification because it requires two steps. You have to prove each step, but but not many of you have done it correctly. So good luck. I will do the question 3 in the next question in the next video.